Hello dear friends, welcome to this video. In this video, we'll be discussing that how the Z root D is the domain. Before we start, we should first understand the definition of the domain. What does domain mean? In an algebra, or more precisely in an abstract algebra, a domain is a non-zero ring in which whenever we have a into b equal to 0, that means a product of two elements equal to 0, then either of the element must be 0. In the simple words, if I want to say, I can say domain is a ring in which the only zero divisor is the 0 itself, nothing else. No other element can be multiplied with something else to get the answer 0. So from this you can understand how the definition of integral domain must have been obtained. So domain is something which has no zero divisor. A commutative domain is actually known as an integral domain, right? So integral domain is basically a domain which is commutative. So if the definition is clear, what I want to prove is nothing but my z root d, my z root d is domain. I want to prove this. And to prove this, I need some pre-requirements so that this proof become very easy. Right? First of all, this z root d is basically all the elements of the form a plus b root d such that my a and b are integers, right? So inside z root d we get the element of this form, but this elements satisfied some properties when we define norm on it. The norm of a plus b root d is basically mod of a square minus db square. This norm is a savior for us because it helps us in many proof for this particular ring z root d. So there are two properties which are required. I am going to state that over here. The first is my n of x, norm of any element is 0 if and only if that element is 0, and norm of x into y is equal to norm of x into norm of y. These are the two major properties which we required. There is one more property based on unity, but over here we will be working on these two properties. So norm of x is 0 if and only if x is 0, and norm of xy is equal to norm of x into norm of y. So with this pre-requirements, we can start the proof. For z root d, where elements are a plus b root d, a and b are integer, what I do is I consider any two element x and y inside z root d, where x is basically a plus b root d and y is nothing but p plus q root d. They will look like this. I don't need them basically over here, but they look like this. I want to show that my if x into y is 0, then I should get x or y, either of them equal to 0. I want to do this. Now, if my x into y is 0, I start from this. If my x into y is 0, this implies me my norm of x into y is also 0. Because we have learned that property x is 0 implies norm is 0, norm is 0 implies x is 0, right? If and only if. And from this, what we have learned this can be written as norm of x into norm of y is 0. Now we are under integer, because if I say norm of a plus b root d, this is basically mod of a square minus db square. So this is basically an integer, right? If it is an integer, I have one integer into another integer, answer is 0. This is only possible if we have n of x 0 or my n of y 0. And from this, what we can say, if my n of x is 0, I can say my x must be 0 or my y must be 0. And from this, what we can say? We can say that my Z root D is a domain. And since we also know this is commutative, if it is commutative, we can even say my Z root D is a integral domain. Right? So in the one, we can have the both the proof. If you want to prove that it is integral, you just prove it is a commutative as well. You are done. Right? I hope you understood the proof and got the clarity of the concept behind the proof as well. If you like the video, subscribe to the channel and share it with your friend and leave your suggestions or the questions in the comment section. Okay? Bye bye.